Hey there. Okay, so we're going to do this problem here. Suppose a scientist wants to create a pool of RNA molecules that are 40 nucleotides long and contain every possible combination of bases. What mass of RNA nucleotides is needed to synthesize the pool of RNA molecules? More correctly, this could be called RNA polymer molecules. That would actually differentiate these better. But anyways, the nucleotides are the individual, right? And so what you're trying to do here is the important part is the fact that it's every possible combination of 40 nucleotides. So how many nucleotides could line up? Well, there's 4 of them that you could get at each spot. So each spot you have 4 options. To get every possible combination, you would have to take 4 and put it to the 40th power, which would be the length of this nucleotide chain or RNA polymer. So 4 to the 40th power would be 1.21 times 10 to the 24th molecules of these RNAs. So the next part you have to do then is we have to figure out, well, we want this in kilograms. We need to get into moles first because moles will allow us to go into grams and grams will allow us to go into kilograms. Again, using the molar mass of the RNA. So next thing we have to do is we have to figure out, well, how many moles of RNA polymer are there? So we take our number 1.21 times 10 to the 24th molecules. We're going to divide it by Avogadro's number, which is the number of molecules that would be in a single mole. And so 6.022 times 10 to the 23rd molecules, we'll divide that. We'll get a number that is ones place because we have 10 to the 24th over 10 to the 23rd. In this case, it'll end up being a 2.01 something moles of RNA polymer. Don't forget, you should never round like I'm showing you here. I just don't want to write out these long numbers. You should always leave the number in your calculator so you don't get rounding errors. Okay, so we have the moles of the RNA polymer. Well, the next thing we need to do is we need to go ahead and figure out, do this next conversion, which is going to be the RNA polymer to kilograms. We'll need the molecular weight of the RNA polymer. And we'll need to remember that, well, each of our polymers has 40 nucleotides. There's a molecular weight number in your book and repeatedly gets mentioned throughout your book. That is this number here, 330 grams per mole of nucleotides. It's sort of an average number for every nucleotide. You have 40 individual nucleotides in the polymer. So 40 nucleotides divided by 1 mole of RNA polymer. That will get us into moles of randomized average nucleotides. Alright, and so you have your moles of nucleotides, then you use your molar mass for an average nucleotide. This is again an average number, 330 grams for 1 mole of nucleotides. You're going to be in grams then. So the next thing you need to do is you need to cancel out grams. So 1 kilogram is 1,000 grams. Ignore that K. Is that a typo? So we cancel out grams, we're in kilograms. That will give us 26.5 kilograms. You'll round it to 3 sig figs because that's what is the... Actually, that's not even the right sig figs. Huh, that's funny. None of our numbers would actually give us 3 sig figs. Anyways, 3 sig figs would be fairly standard. This number probably is 330 point just period, which would be 3 sig figs. typically most molar masses or 3 sig figs would be an acceptable place. Only the better determined molar masses would be 4 or 5 or even 6 sig figs. So that is kind of funny though. Most of the numbers here are actually kind of off. Anyways, so 26.5 kilograms. It's biochemistry. We don't need to have perfect sig figs, I guess. Anyways. Let me know if you have any questions or you didn't understand anything about this. It's actually a fairly straightforward problem. The two parts that typically bug people are the 40 to the 40th power, or 4 to the 40th power, because they don't understand or they didn't pick up on that it's a 40 nucleotide long polymer that has every combination. So we have a pool that's every combination. So 4 different things that could be there, 4 to the 40th power, much like if you took heads and tails on a coin, it would be 1/2 or 2 to the whatever power. And the other thing that people have issues with sometimes is they don't have this generalized number, in which case they'd have to either look it up or they'd have to get an average themselves. This problem would be much, much harder if we don't do an average number here and we did an individual number. But then again, you could do a weighted average. So you just take the 4 different RNA nucleotides and you calculate their molar weights or molecular weights, molar masses, and then you'd get a sum of those numbers and divide by 4, and that'd be an average. And that'll come out something about that. Close enough that you'll get the final answer here. Though honestly, it's a much easier problem if you just use the number that you can find in your book and are oftentimes provided. Anyways, let me know if you have any issues or any problems.